So this is number 7 on our repeat sheet.
How do we use this? This is always just going to be geometric.
Okay, let's take a look at what the guys came up with. How do the pictures look first of all? Do the pictures look okay? So A and C are both just regular decay things. So they came up with equations 2 times 1/2 to the x, 2 times 1/3 to the x. Are those fine? Yeah. The number out in front doesn't matter, but it's gotta be positive. And then the number inside the parentheses less than 1, perfect. And then B's equation was -2 times 5 to the x. Did you recognize that, first of all, that's upside down. And it's the upside down of this, which is a growth problem, hence the 5 here. And then, but it's upside down, so the -2. All right? No questions? Everybody feeling very happy about that? All right. Oh, D is another one. The initial value is 6. What does that mean when we say the initial value is 6? What is that? Y-intercept. So whatever's happening, my y-intercept is 6. And my exponential equation will be y equals 6. And it's decay. So I can put whatever I want in here, 4/7, as an example of an equation for that one. All right. I do not know. Number 8. The number of meals served in the dining hall each day has been increasing steadily each week. That confuses me. Third week was 254, and 15th week was 458. And we went through this. What does increasing steadily mean? Going up by the same amount? Is that how you interpret that word? Yeah, I think if you make an argument the other way, I have to be more careful when I write these questions, but I think it's arithmetic, increasing by the same amount. I mean, actual numerical amount. So, if it's arithmetic, that means that I have to take 12 equally spaced steps. Add D, add D, add D, add D 12 times. And cover this total distance, which is 204. Which means my steps must be 17 big. What does that 17 represent? 17 what? 17 meals per week? Is it per day or per week? Per week. We're going up by increments of 17 each week. All right, so then what's the 36th one gonna be? Well, how many steps do I have to take? 21. And they're all 17. And add it to 458. Did you get 815? Okay, don't just sit there and stare at me. Challenge me. Is it right? You agree with it? Okay. All right, number 9. Oh boy. Oh boy. All right, what are we gonna do with this guy? I hope you're gonna factor it. On the bottom, take out a 2. And then you'll have x squared minus 1, which factors like that. All right, can we all get to there? Can we all get to here? I hear talking. Are you guys okay?
Yeah, I'm just trying to figure it out.
This
The
one?
last problem, yeah.
What? All right, everybody else here? Okay, so we don't need some big elaborate graph, but we are gonna need a graph because we gotta answer these limit questions. So tell me what you know. I know we're gonna have a hole at -1. And it will be where? -5/4. Double check that. My hole's at -1 because that's what canceled. So when I plugged in -1, I got -5/4. All right, what else can you tell me about my picture? I have a vertical asymptote at 1. That's where I'm undefined. Where's my horizontal asymptote?
1/2.
1/2. And how do I know it's horizontal? That's an end behavior asymptote. How do I know it's 1/2?
Because the X's on the top and the bottom both have the same, dang it, X.
Yeah,
Yeah.
that's right. How about intercepts? My x-intercept is gonna be out here at -6. And how do I get my y-intercept? Plug in 0. Now, those are the key things. Does anybody have a question? Have you forgotten how to get one of those things? Anybody have a question about any of that? So now I'm gonna go ahead and draw my picture, connecting the dots. And this is gonna continue to get closer and closer to that asymptote. And don't forget, there's a chunk over here, right? Based on that, I should be able to answer the questions. A, what's the limit as we approach 1 from the left? Here's 1. As we approach from the left, what's happening? Negative infinity. So the answer to A is negative infinity. It's a vertical asymptote. When you come at it, you either go up or down. In this case, on the left, we're going down. What happens as x approaches infinity? So x is going clear across the hall. What's happening? We're getting closer to 1/2 from the top. What happens as we approach -1? Now here's where x is -1. That actually is a point, not an asymptote. So it doesn't really matter which side I come at it from. Aren't I coming to the same place? So the answer to C is -5/4. And then what happens is we approach negative infinity, so we're going this way now, negative infinity. Again, we're getting closer to 1/2, but this time it's from the bottom, from underneath. Everybody okay with that? 10 says, what's the end behavior asymptote of this? Well, the end behavior asymptote of this is not going to be horizontal, because as Charlie said, the exponents don't match, the powers don't match. So it's going to be a slant, and how do we find it? Do our division. And what goes in the box here? 3. So my slant asymptote is 2x minus 1. I did my division right? Okay with everybody? Okay, now I'm going to have volunteers come up and put the next, these are average rate of change. Oh my gosh, this is like from day 1. Average rate of change. But remember, every time you are asked specifically for an average rate of change, for problem number A, for example, you are going to start out with f of -1 minus f of -2 over -1 minus -2. Remember that little formula we have? F of b minus f of a over b minus a. That is how they're all going to start. So there's the first one I got set up for you. B and C, you guys are on your own. And notice that we're finding the average rate of change of an equation, of a picture, and of a table of values. That doesn't change anything about what you do, it just changes what it looks like. if I match. I match everybody up here. Now, I love that you put a unit on C, but this is a rate of change, right? So it shouldn't be like miles, it should be like miles per hour. This one's kind of tricky though, because it is years, but it's like years per year, so it's kind of weird. So it's like years of age per year of passing time. So every year, is this women? A woman could expect to live 0.2382 more years than she did the year before. So I don't know how you would say that. I would probably just say years of age per years of time. But I love that you put a unit on that. Can't really put a unit on the other two because they have no context. But I love, everybody used the right letters. B used G, C used A, right on target. Perfect. Any issues there with anyone? Good? All right. Another one of these, linear, quadratic, or neither. Let's go ahead and throw exponential in there too, in case we find an exponential, because that's part of our repertoire now. So linear, quadratic, or exponential. Let's look at it and see what you think. Any thoughts on A? Quadratic? Why do you think it's quadratic then?
Because it's like your rate of change is constant, but although it's not over like constant intervals.
Yeah.
So it's
That's the problem, yeah. So this one is neither, because we're not increasing, our input intervals are not the same size. Did you notice that? So even though the y's, the outputs, look quadratic, you can't say that because the inputs are not the same. All right, what about B?
Linear.
B is linear, you say? Let's see. I think she's right. Why is B linear? Because when you find like the slope, the average rate of change between each consecutive set of points, it comes out the same. Good call. Okay, what about C? That one is quadratic. Will, there you go. That one is quadratic. Perfect. All right, 13. Anybody feel confident in solving 13? Can you come to the board to solve it? Little polynomial. I see a bunch of people writing. Let's not be chickens. Okay, I even erase the board for you. Somebody come up and do it? Thank you, Celeste. Violet, you're on call. You're coming soon, okay? boy, Celeste, thank you. That matches what I got. Thank you very much. Anybody have a question about what Celeste did? She factored by grouping. Did a little sign chart on her number line. You good? All right, last page. When we're done with this, we'll take 4 more questions or whatever you want to do. Determine the degree of the polynomials represented in these tables. Now, let's look at those x's first. Are our x's, our x input values, are they evenly spaced? In both columns, or both charts? So we are good to look at the first differences, second differences, third differences, and so on. Do you remember that rule? If the first differences match, you're linear. If the second differences match, you're quadratic, and so on down the line. So we just want to find out where the differences start matching. What'd you get for the first one, A? Quadratic. The degree would be 2, the degree of the polynomial would be 2, it's quadratic. Perfect. And what'd you get for B? Cubic, third degree. Third differences match. Anybody have a question about that? All right, let's look at the next. Same thing, except now we're talking about concave up or concave down. Now, what does that mean in terms of the chart? I know what concave up and down means, but how do I use my chart to tell me that?
Is the rate of change increasing or decreasing?
Exactly. So we're gonna find our rates of change. So like the slope between each consecutive set of points. And then you're gonna look to see if those slopes are going up or going down. So for example, just to make sure everybody's on target here. Oh no. So my first slope would be -3 over 0.1 or -30. My second one would be -2 over 0.1 or -20. And my last one would be -1 over 0.1 or -10. What is happening to the average rate of change? It's increasing. Aren't these numbers getting bigger? And if your rate of change is increasing, then you are concave up. Concave up. All right, do the same thing with the other 2 charts, and let's see what we can come up with. Obviously, if the rates of change are the same, you don't have any concavity, you're a line. Oh, is that what happens in B?
Yeah.
All right. So that's a line. And what about C? Concave down? because the rates of change are decreasing. All right, guys, 2 more problems. Here we go. The number of cars in a parking lot can be modeled by this function. Based on this model, at what time does the number of cars in the parking lot change from increasing? Think about that now. The number of cars in the parking lot is increasing, and then it changes to decreasing. What does that mean I'm looking for? A maximum? So I'm gonna graph that guy on my calculator, and I'm gonna find the maximum. Notice you're given a domain, 0 to 3. What's that? X, min, and max.
Get it? It's not working. It's like somebody
Did you find a maximum? Caitlin, what'd you get?
0.470.471.
That's not what I got. Anybody else get that?
Or 3.
No, 3 is, oh, I don't know, 3, is that your Y coordinate? No, we want the X coordinate. Somebody give me another one. 2.446 hours, that's what I got. So make sure, Caitlin, you type in your equation right.
Yeah, I just looked.
2.446. The thing I want everybody to catch there is, what are you looking for? The number of cars changes from going up to going down. That means you want a maximum, right? Yeah. Okay, number 17. So the picture's drawn. On each interval, determine if the rate of change is increasing or decreasing. So from 3 to 4, from 3 to 4, is the rate of change increasing or decreasing? Increasing. Why is it increasing? Because it's concave up. How about from -4 to -3? The rate of change is decreasing, so therefore, wait, one more time. Is the rate of change decreasing? Yes, we're decreasing. So that means, I guess it doesn't say that, but the rate of change is decreasing, it's going down.
I thought it was
No, stop. Back up. I'm having a bad, awful day. All right, let me go back to A. From 3 to 4, we're concave up, so we're increasing. From -4 to -3, we're concave up, so we are increasing. Is that better? Okay. Now, is the function increasing or decreasing? Well, from 2 to 3, the function is increasing, but it's negative. The function's negative, but it's increasing from 2 to 3. from -3 to -1. Got a little bit of both going on.
Yeah.
So it's decreasing on the first half and increasing on the second half. Okay? All right. Anybody have a question about homework or anything else before our quiz on Tuesday?
Can I see your? Why do you have so much work? What do you do this? I got 5.
It always dies when it turns on.
Those of you that just turned your homework in today, I'll have that graded by Monday if you wanna come by and look at it.